Alright, this is our triangle and exterior angle sum theorem, lesson 5.05. We want to talk about the triangle angle sum theorem, and in this particular case we already did in Unit 4. Remember that a triangle is a three-sided polygon, and the interior angles of a triangle are the three angles that are inside the triangle. The sum theorem states that the sum of the measures of the interior angles of a triangle will be 180 degrees. Let's go ahead and take a look at an example where we can apply this theorem and that understanding. So I have this triangle here where we have to figure out the measure of angle T. We know that the sum of all the angles in the triangle adds up to 180 degrees. So we have two angles, A and M, that we both know the angle values of. So we have the measure of angle A. The measure of angle A is 27 degrees. The measure of angle M is 82 degrees. So we know that we can take both of those angle values and add them together. 27 plus 82, which is 109 degrees. This is the total sum of all the angles that we know in the triangle. So how much is the missing angle going to be from our total? We know the total is 180, and we can subtract 109 from 180, and we end up with 71 degrees. So the measure of angle T is going to equal 71 degrees. This demonstrates how you can use your understanding of the triangle angle sum theorem to determine a missing angle inside of a triangle. So go ahead and pause the video and see if you can apply the triangle angle sum theorem to find the missing value located at the measure of angle 7. In this problem, we know that the measure of angle A plus the measure of angle B plus the measure of angle S is going to equal 180 degrees by the triangle angle sum theorem. We can replace the measure of A with 65, the measure of B with 45, and we're finding the measure of angle S, the missing angle. So we can add our known angles together to get 110 degrees, and in this case we have the missing measure angle 7 as well. We know that their sum is still equal to 180. Now we can go ahead and subtract 110 on both sides. When we subtract 110 on both sides, we end up with the measure of angle S. We end up with 70 degrees. So the missing value you should have arrived at is 70 degrees for the angle that's created there. Now, we want to use what we actually know. Information that's available to us when it comes to angles, and those are properties, right? We know that supplementary angles add up to 180 degrees. We know that complementary angles add up to 90 degrees. We know that a linear pair is going to add up to 180, and it's going to make a straight line. We also know that vertical angles are across from each other, so they're opposite each other in a sense, and they're equal to each other. And then, of course, as we just discussed, we have our triangle angle sum theorem, which is what this is referring to here, specifically the interior angles, right? The interior angles add up to 180 degrees. Okay, so with that being said, to find the missing angle value like we just did in previous examples, we look at what's given and we look at what's needed to be found, the thing that you're missing, in other words, and then we have to plug in what we're given or what we know. We have to refer back to any properties or definitions or theorems or postulates that we know, and we have to think of steps that we can do to get, from the beginning of the tunnel to the end of the tunnel. Where do we start and where do we want to end up at? So I would recommend that you use reference sheets, your reference sheets on things like this, meaning that any slide that we've provided you that has information about a property, a definition, theorem or postulate or axiom, you want to utilize those when you're trying to solve problems like, for example, what we're doing here. So let's take a look at another example where we have to determine the measure of missing angles. And what we want to do is kind of use information about the diagram, such as a definition perhaps, or a property of the type of figures that we have to help us answer the question. So in many ways, what you want to try to do is figure out what is the easiest angle to find first. And the easiest angle to find first is always the angle where the information is essentially automatically given to you. You didn't have to subtract or add anything to get it. It's already there right in front of your eyes, okay? So if you take a moment to look at the angle ECD, this angle right here would normally be considered the easiest to find, and there's a reason for that. I'm going to go ahead and kind of outline this, but this triangle here on the top, we should also be able to recognize what type of triangle that is. The triangle CDE is an isosceles triangle, so it is isosceles. Now, if it's isosceles, that tells us information that we know about the base angles, right? So, of course, you see the side lengths are the same, but that also means these base angles will be congruent to each other. So, the angle ECD is going to be congruent to the angle DEC. Those are called base angles, right? So, the base angles are congruent in an isosceles triangle. That's a property of an isosceles triangle that you should be aware of that we've talked about in the past. So what does that tell us? Well, what that tells us is that the measure of angle ECD is going to then equal 64 degrees, and that is a value that is provided on our triangle image there that we have. Now, there's lots of different ways that you can go about doing this, okay? Several different theorems that you could refer to. So I'm going to list out a couple things that would be useful for us. Of course, we have the triangle angle sum theorem, right? So the triangle sum theorem, that's something we could use. You could use the triangle exterior angle theorem, which we've talked about in the past. And if you look at the fact that we have a linear pair available in the diagram, we could also use that as well. So this is what I'm referring to when we're talking about properties and definitions and such. So let's go ahead and find the measure of angle D now. So the measure of angle D is up here. This one is one similar to what we had in the previous examples on this lesson, which is that we're missing a third angle and we have two angles that we know. So therefore, the measure of angle D is going to equal 180 minus 2 times 64. So that's 180 minus 128, and that's going to equal 52 degrees. So now we have our second angle value that was missing in the diagram, 52 degrees. Now, again, lots of different approaches can be made to find the final angle, the FCE, if you will, that we're looking for here. For me, I'm going to go ahead and utilize my understanding of a linear pair to find it. So the angle of FCE, I recognize that it forms a linear pair with this angle. That means both these angles are supplementary to each other, so they add up to 180. So I could take 180 and subtract 64 degrees, and that's going to get me 116 degrees. So the reason I actually found this one in particular is because I was thinking of using a linear pair, right? So this I used a linear pair. Technically we call it the linear pair postulate, but it's the properties of a linear pair that I used to find that angle. And then of course with this angle I'm using that triangle sum theorem to find, and then I used the property of isosceles to find the base angle that was missing at angle ECD. So this is what we're referring to when we talk about, using previous postulates, definitions, and theorems and axioms and things like that to help us find missing values. So let's take a look at this example here. What is the measure of angle K? So there's lots of ways that I could go about doing this. However, one thing I did notice is that W is an exterior angle if you compare the angle W with the triangle on the right. So if I just draw a general shape here, here's W, here's 57, and here's 40. So, angle W is exterior to the right triangle. So because it's an exterior angle, I know that the measure of angle W is equal to 57 plus 40. Remember that those are the remote interior angles of the triangle. So I know then the measure of angle W is equal to 97 degrees. So now I have an angle in the left triangle that I now know is W, which is 97. I have 26. So by the triangle angle sum theorem, or the triangle sum theorem, which I'm just kind of abbreviating here, I know that the measure of angle K is going to equal 180 minus 97 plus 26. So that's going to end up getting us 180 minus 123, and that gets us 57 degrees. So the measure of angle K is a 57 degree angle, and the measure of angle W is a 97 degree angle. And I utilize the exterior angle theorem officially to find the measure of angle W, right? So when we talk about the exterior angle theorem, I'm actually utilizing that here to find the measure of angle W, and then I use the triangle angle sum theorem to find the measure of angle K. There are other ways you can do this, but this is just an example. Okay, so let's go ahead and take a look at one final example. And there's several examples actually that are all similar to each other in what they're targeting. So I just want to briefly reference, before I talk about the final example, that each of the examples that are left on the presentation that your teacher will provide you are asking really for the same exact thing. It's just different values are provided to you. So what I want to talk about is that when you have tougher problems to deal with, just remember that the triangle angle sum theorem is ultimately a really very applicable and useful theorem that you can use. And we want to combine our algebra knowledge, our algebraic knowledge, as well in conjunction with that theorem to help us figure out the value of a variable and then therefore the value of an angle. So we can actually use it to help solve types of equations, which is really what the last type of problem is that you'll see in your lesson today. So if you look at this example right here, this is a really good representation of the last type of problem today that we need to target. We're trying to figure out the measure of angle x, and we're given all of the different angle values and expressions that are provided that you see there for each angle. So we recall that the sum of all the angles in a triangle equals 180 degrees. So what I can do is I can take each expression for each angle and I can add them together. So I have 2x minus 7 plus 6x minus 3 plus 7x plus 10, and that's going to equal 180 degrees. I recognize that the 2x, the 6x, and the 7x are like terms, while the negative 7, the negative 3, and the positive 10 are like terms. So I can combine those together to get 15x, and it just so happens that negative 7 and negative 3, or minus 7, minus 3, and positive 10 actually cancel each other out. So in other words, I have nothing there, it's plus 0. So we just have 15x is equal to 180, and I can go ahead and divide by 15 to get a value of x equals 12. So with that particular value of x, I can go ahead now and take the expression for the angle x and the measure of it, and I can plug 12 into the value of the variable x. And so here I end up with 24 minus 7, and that is equal to 17 degrees. So this is how I could find the missing angle of a triangle where the angle is expressed with an algebraic expression, and I'm using the triangle angle sum theorem to achieve this. So your exit ticket here is going to represent very much the same process. In fact, the first two questions that you see here and here, I would recommend you refer back to that very last example that I talked about to help you and assist you with solving for that particular value of the angle that you have there. And then lastly, the question on the far right, you're finding that angle 1 is 95 degrees and that angle 2 is 36 degrees. So how can we use angle relationships to help us figure out what angle 7 is? My recommendation is to think about the angles that you have right here at 4 and at 6. How can I use those two angles to help me find the measure of angle 7? And that is going to represent our lesson for 5.05.